Hi, this is Professor Anil Kumar Sathe from Department of Mechanical Engineering, MIT School of Engineering, Pune. In continuation with the last lecture, we are going to study work required to drive the compressor when clearance volume is considered. Just recall the last lecture. What you have studied there? We have seen the derivation for work required to drive the compressor when clearance volume is neglected. Now here we have to derive the equation for work when clearance volume is considered. Now let's try to understand the difference between clearance volume is neglected and clearance volume is considered. Clearance volume considered means it is a practical case. Just look at this figure. This figure need not to draw when this question is asked in the examination. Only this figure you need to draw if the derivation is asked. This figure is not required. Why I have given here? Only for the clear understanding of the derivation. Now just see here. This is your cylinder head. This is the top dead center, means the volume enclosed when piston is at top dead center above the piston, it is a clearance volume. You can see here it's a VC. The volume covered by the piston while moving from top dead center to bottom dead center, means this volume, it is given by the stroke volume Vs, and Vs plus Vc becomes a total volume. So this figure clearly says clearance volume is present in the compressor. Now your cycle starts from top dead center, that is 0. You can see here on a PV diagram now, I have shown clearance volume here. I have not started 0 from y-axis. I have taken some distance here. So this distance indicates the clearance volume Vc on a x-axis. So 0 is here, away from cylinder surface, that is y-axis, 0. So 0 to 1 is suction, 0 to 1 is suction, 1 to 2 is a compression, 1 to 2 is a compression. Purposefully I have drawn a different lines. This indicates your first stroke and this indicates your second stroke, and the cycle is completed. So 0 to 1 is suction, 0 to 1 is suction, 1 to 2 some intermediate point during upward travel of the piston, 1 to 2 is a compression, and from that intermediate point to the top dead center, as at this intermediate point delivery valve opens. This I have already explained in the previous lectures. So 2 to 3 is only delivery process, 2 to 3. Now from 3, this is the end of the cycle, no doubt. But in the next cycle what happens? Can you tell me, at the end of the first cycle when piston is completing the delivery and reaches to top dead center, what is present in clearance volume? In clearance volume, residual air is present, and which is at discharge pressure P2. When the piston starts moving down during suction stroke of the next consecutive cycle, your suction valve will not open exactly at top dead center. It takes certain time. Why it takes time? Because here already there is a residual air and that is at pressure P2. So your suction valve will not open at top dead center, because you know in compressor suction valve is open automatically when the pressure inside the cylinder drops below atmospheric pressure. So when the piston starts from top dead center, it takes certain time to drop the pressure below atmospheric. So from 0 to 4, the air present here, that is a residual air present in a clearance volume, get expanded, and that is shown by the process 3 to 4. As it is reached 3 and 0 is same. So 3 to 4 is the expansion of that air, and at point 4 the pressure is dropped below atmospheric. Okay. So therefore at point 4, this point 4 indicates the point at which your suction valve open. So from point 4 to 1 only air starts coming in. During 0 to 4, as suction valve is not open, because that stroke is going west for the expansion of already present residual air. So 0 to 4 is a idle suction stroke and 4 to 1 is a effective suction stroke. So you tell me what is meant by effective suction stroke? Effective suction stroke is a suction stroke during which actual suction valve is open and air starts coming in or sucked in. 0 to 4, yes, it is a suction stroke, but suction valve is not open, so this stroke goes west. So you can see 0 to 4 this volume is not utilized for suction. Air comes only from 4 to 1 because at point number 4 your suction wall is open. So your 4 to 1 is your effective suction. So now if such a case is there, how to calculate the work required? Now this is the PV diagram when clearance volume is considered. Have you understood it? Okay, we'll go ahead now. So what is W now? As compressor is open system, area of the cycle or a loop on a PV diagram is a work. So what is the cycle here? It is 1, 2, 3, 4, 1. Why it is not start from 0? Because now here expansion is there because of that residual air. So cycle is 1, 2, 3, 4, 1. So area of this loop is called as work required to drive the compressor when clearance volume is considered. So how to calculate this area? 1, 2, 3, 4, 1. This area we need to calculate. So it is simple. Again a graphical, we can express this area is W is equal to area behind the curve 1 to 2. Means which area? This area. You can see here the cursor movement. This area behind the curve 1 to 2 is which area? See, I am moving the cursor on the border. Minus area behind the curve 3 to 4. Which area? 3 to 4. This is 3 to 4. So area behind the curve is this one. See the cursor motion. And then if I am subtracting these two areas, I will get the area of this loop, and loop means 4, 1, 2, 3, 4. This is your work required to drive the compressor when clearance volume is considered. Now just leave the figures, we will proceed with the derivation. Now area behind the curve 1 to 2 you have already derived in the last lecture. What is that? W is equal to n upon n minus 1 P1 V1 in bracket P2 by P1 raised to n minus 1 upon n minus 1. So we are taking the reference of previous derivation here. Now as you know this for process 1 to 2, similarly you can write for 3 to 4. Same expression you have to write for 3 to 4. How you are writing this? You are writing by this way for 3 to 4. Okay, this is 3 to 4. Area behind the curve 3 to 4. And area behind the curve 1 to 2, we are taking the reference of last derivation. This is already derived, put it here. Okay, so we are getting W, area behind the curve 1 to 2, this one, and area behind the curve 3 to 4, this one is this. Okay, so after putting the values of expression for W, we will get the final equation like this. Area behind the curve 1 to 2 and area behind the curve 3 to 4. Subtraction. Now just look at this. We will simplify this equation further. Now you know P3 is P2 and P4 is P1. Just look at here. P3 is P2 and P4 is P1. It can be clearly understood from the diagram. P3 is P2 and P4 is P1 because they are on the same line, constant pressure line. P4 is P1 and P3 is P2. That's what I have written here. Okay. Now put these values in this expression. N upon n minus 1 P1 V1, P2 by P1 raised to n minus 1 upon n minus 1. First term is as it is. Only the second term is changing. P4 value is written as P1. You can see P4 is replaced by P1. And P3, you can see here, it's a P3. P3 is replaced by P2. So P2 is coming here. Everything remains same. So this derivation is modified by putting the values of P3 and P4 as P2 and P1 respectively. And I am getting a new equation here. Now you can see here blue color. These things are common in these two terms that I have taken outside. So n upon n minus 1 P1 is common. And what remains in bracket? V1 minus V4. Even this bracket is also common. So this bracket is a common. So final expression is this one. What is this? It is work required to drive the compressor when clearance volume is considered. Now we have seen last expression where clearance volume is neglected. Just recall that expression. What is that expression? Similar sort of expression is there. Only instead of V1 minus V4, there is only V1. Only V1. So, same derivation, expression is same, only difference is there only V1 when clearance volume is neglected. Here V1 minus V4 instead of V1 when clearance volume is considered. Derivation is same. Now, there may be a confusion in student mind. If the derivation is asked for work required to drive the compressor when clearance volume is considered, only this much we have to derive? No. You have to derive initially this expression that we have seen in last lecture when clearance volume is neglected, and there onward you have to start from, you have to draw this figure, and you have to start from this to arrive at this final expression. You can't straight away start from this, from here, otherwise your marks are reduced. So remember, when work required to drive the compressor when clearance volume is considered, that is asked in the examination, first you have to derive the equation for work when clearance volume is neglected, and by taking the reference of that equation, you have to sketch this figure and you have to start from here to arrive at final equation. So that's it for today. Thank you.